Hello students, welcome back to our channel. I am Anisha, your maths faculty, and we are doing chapter 5 of your NCERT book, that is the continuity and differentiability. And we have started in this exercise 5.4, and it's I think second video of your exercise 5.4. We have completed question number 1, 2 and 3. In this video, we will cover question number 4, 5, 6 and 7 of your exercise 5.4. Okay, let's begin our video. You know our like what is the motto of our channel? मैथ्स को कैसे हम सिंपल और इंटरेस्टिंग बना सकते हैं. Let's go there. Okay. So this is question number 4 of your exercise 5.4. Okay. In each question, what we have to do? We have to differentiate the given function with respect to x. Okay. Let's start. This is our question number 4. So to write it again, like ये बहुत बड़ा expression है, तो मेरे को इसको बार बार लिखना नहीं है. तो हम क्या करते हैं? I have always said you give them a name of variable. So let's take it as y. So this is our dy by, y is sine of tan inverse of e raised to minus x. Okay. Now, as we have to like differentiate it with respect to x, so what we have to find now? So our to do will become to find dy by dx. Now let's find our dy by dx. देखो अभी तक बहुत टाइम हो गया हमको कंटिन्यूटी डिफरेंशिएबिलिटी के क्वेश्चंस करते करते डी वाई बाय डीएक्स निकालना, तो मतलब ऐसा ओ भाई हर क्वेश्चन में तो हमको डी वाई बाय डीएक्स निकालना होता है. लेकिन अब थोड़ा सा लेवल बढ़ रहा है. जैसे हमारे गेम्स में लेवल होते हैं, ऐसे इसमें भी लेवल बढ़ रहा है भाई. कंपोजिशन में कंपोजिशन ऐड हो रहे हैं, एक्सपोनेंशियल ऐड हो रहा है, इनवर्स ट्रिग्नोमेट्री ऐड हो रहा है. बस अब लेवल्स बढ़ रहे हैं. करना वही अपना बेसिक चीज है, अपने को करना डिफरेंशिएट ये फंक्शन को. ओके, सो लेट्स स्टार्ट. Okay, so see, I have given you the funda in previous video that how to find our dy by dx. Okay, so if you are like didn't watch that video, so I will tell you here also what is the funda. Our funda is first check whether it is a standard differentiation of a given function, of like standard function differentiation or not. Then check if you can apply your UV rule, or consider both in both cases in step 2 only, like UV rule or quotient rule, that is U by V rule. Okay, then third check, like if all of this are not coming, this as I have taken the third case in second also, second only. So now our third will become only chain rule only possible, that is chain rule. So when this chain rule comes when there is a composition of function. Okay, so now as you can see, I cannot see some standard differentiation because it's like combining of बहुत सारे फंक्शन हो गए भाई. साइन भी हो गया, यहाँ पे tan इनवर्स भी हो गया, एक्सपोनेंशियल भी आ गया, तो ये तो बहुत सारा हो गया. तो कोई स्टैंडर्ड तो मेरे को दिख नहीं रहा, ना यूवी रूल दिख रहा है, ना क्वोशिएंट रूल दिख रहा है. तो हमारे पास क्या बचा? लास्ट ऑप्शन, दैट इज कंपोजिशन. So as you can see, we can like write this function in composition of three functions. Okay, if you are like if I try to explain, this can be written as composition of three functions. Take your outer function as u of x as sin x. Take your inner function, that is v of x as take it as v of t. Your v of t as tan inverse of t. Then the last is w of, this should be t, I think. Yeah, this should be t, so that composition will become easy. There is no need to, but like चीजें आसान रहे, इसीलिए हम ये करते हैं कि जो सबसे अंदर वाला फंक्शन है उसको x के साथ लेके चलते हैं. तो हमें एक काम करते हैं, हम अंदर से ही स्टार्ट करते हैं. हमें पता है कि पहला फंक्शन जो आउटर फंक्शन होता है साइन होता है, वेरिएबल बाद करेंगे. ओके, फिर उसके बाद होगा अपना tan इनवर्स, फिर लास्ट में होगा अपना w इज एक्सपोनेंशियल फंक्शन. ओके, तो वैसे देखने जाए तो e रेज टू माइनस एक्स होना चाहिए, तो e ऑफ माइनस एक्स. सो हम एक्सपोनेंशियल, क्योंकि हमें x में ही रखना है पूरा फंक्शन को, दिस मतलब राइट हैंड साइड विल थिंग शुड बी इन x. तो हम क्या करेंगे, दिस शुड बी अ वेरिएबल x. नाउ अब इनको जो वेरिएबल देना हो, आई विल टेक t, आई विल टेक एज से r, तो हो गया. सो अवर y इज अ कंपोजिशन ऑफ दिस थ्री फंक्शन. ठीक है, सो अवर y विल बिकम u composition v composition w. Okay, so now what we have to do, we have to just apply the differentiation in the composition of function. In this there is no hard rule. I have also told in my introduction video. अगर आप लोगों ने introduction video पढ़ी होगी, देखी होगी, तो ठीक है, आपको डायरेक्टली आप तो इसको लिखना स्टार्ट कर चुके होंगे, लेकिन इफ वो भी नहीं देखी तो मैंने एक्सरसाइज 5.4 के बिगनिंग में भी हमने डिस्कस किया है कि हम कैसे कंपोजिशन ऑफ फंक्शन को डिफरेंशिएट करते हैं. सो आई विल नॉट रिपीट दैट थिंग हियर अगेन. इफ यू हैव डाउट, if you don't want to see that whole introduction video, leave it. Just see the beginning video of this exercise 5.4. That is the previous video only. Okay, so I will do the differentiation here only. So what we have to find? We have to find dy by dx. So what I always told how to find its differentiation. So as we have to like apply the chain rule. So differentiate the outer function, take the argument as it is, then differentiate your argument. That means this. So okay, if I write, so my y is okay, as I will write it here again. So my y is sine of tan inverse of e raised to minus x. So, so to differentiate y with respect to x, this will become differentiation of sine, that is cos, differentiation of sine, that is cos, and take the argument as it is. Then differentiate your argument with respect to x, that is by dx of tan inverse of e raised to minus x. If I try to, like, if I write the reason, as I always told, what you are doing, just write the reason. This reason is not necessary. I am writing this reason so that you can understand what I am doing, how the chain rule works. So, differentiation of sine of f of x is nothing but differentiation of sine, that is cos of f of x, take the argument as it is, then differentiate the argument with respect to the variable, that is d by dx of f of x. Okay, so now let's move ahead. So now we have to find its differentiation. So our dy by dx is cos of tan inverse of e raised to minus x. Then what we have to do? We have to differentiate tan inverse of e raised to minus x. Here also you will do differentiate the outer function, that is with the argument as it is. So we know that the differentiation of tan inverse of x, the derivative is nothing but 1 upon 1 plus x square. So I will use it. So this will be 1 upon 1 plus e raised to minus x square, because here our argument is e raised to minus x. Now differentiate the inner argument, that is dy by dx. Differentiate the inner argument. So this will comes out to be, I will write it here. This will be 1 upon 1 plus e raised to minus x whole square. Then differentiate your argument e raised to minus x. Okay. So now dy by dx. So this will become cos of tan inverse of e of minus x dot 1 upon 1 plus e raised to minus x whole square. Now differentiate your dy by differentiate of e raised to minus x. So it should be, as we know, its differentiation is e raised to minus x. Now differentiate its argument. Its argument is minus of x. So that is d by dx of minus x. So this whole will become cos of tan inverse of e raised to minus x dot 1 upon 1 plus. I am doing each and every step so you guys will not confuse here. That's why I'm doing each and every step, because I know I am doing, like, I am writing a lot, but ठीक है, एक बार तो हमें properly सारे steps के साथ करना चाहिए, so that हमें पता चले हाँ कि भाई चल क्या रहा है हमारे क्वेश्चन में. So this is minus of e raised to minus x cos of tan inverse of e of minus x divided by 1 plus e of minus x whole square. This is our dy by dx. This will be our final answer. Okay, I think you guys understand this. Okay, now कुछ नहीं करना है हमको, बस कंपोजिशन ऑफ, अगर हमारे देखो फंडा क्या था कि देखो स्टैंडर्ड डिफरेंशिएशन है कि नहीं है, नहीं लग रहा है यहाँ पे. फिर देखना क्या था हमें कि यूवी या फिर यू कोशेंट वी रूल लग रहा है, नहीं वो भी कुछ नहीं लग रहा है. तो हमारे पास क्या स्टेप बचता है, वही चेन रूल वाला. हमको कंपोजिशन दिख रहा है, लगाओ कंपोजिशन, कंपोजिशन का डिफरेंशिएशन हमें आता ही है. ठीक है, चलो let's move to the next question then. Okay, so this is question number 5, that in here also take this as y is log of cos of e raised to x. Now I think you can do it by yourself. This will be homework for you, because इसमें same करना है हमें, same as it is. यहाँ पे भी कंपोजिशन ऑफ 3 फंक्शन ही है, दैट इज लॉग, देन कॉस, देन एक्सपोनेंशियल फंक्शन. बस वही कंपोजिशन ऑफ फंक्शंस को डिफरेंशिएट करना है. दैट मीन्स लाइक चेन रूल लगानी है और कुछ नहीं है. दिस विल बी होमवर्क बिकॉज इट विल फॉलो द सेम रूल एज क्वेश्चन नंबर 4. ओके, सो व्हाट आई एम सेइंग इज, आपको ना ऐसे जिसमें बहुत सारा कंपोजिशन लग रहे हो, जैसे यहाँ पे 3 बार कंपोजिशन लग रहा है, यू शुड ट्राई टू डू दिस टाइप ऑफ क्वेश्चंस once by yourself. Why? Because this can be like this type of questions contain that weightage that they can be asked in your exams. And ऐसा कोई फिक्स रूल होता नहीं है कि भाई ये वाला ही क्वेश्चन उठ के आएगा, ये वाला ही क्वेश्चन उठ के आएगा. होता क्या है बस, हाँ, नंबर चेंज कर सकते हैं, फंक्शंस इंटरचेंज कर सकते हैं. सपोज अगर मैंने अब क्वेश्चन नेक्स्ट बना दिया कि दिस विल बी कॉस ऑफ लॉग ऑफ ई रेज टू एक्स. नाउ इसका डिफरेंशिएशन फाइंड करो विद रिस्पेक्ट टू एक्स. कुछ नहीं करना है, बस अब मैंने कंपोजिशन में फंक्शन इंटरचेंज कर दिए. जो अंदर था उसको बाहर ले लिया, बस मिडिल वाले को मैंने बाहर ले लिया है. बस सेम चीज हमें फॉलो करनी है. कंपोजिशन ऑफ फंक्शन बना, उसको कंपोजिशन ऑफ फंक्शन में कन्वर्ट किया, देन डिफरेंशिएट इट बाय यूजिंग चेन रूल. ओके, now this is homework. So I think if you have doubt in this question, you just ask me. Just write in comment section. I will do it for you. But I think you can easily do it. There will be no need to ask in the comment section. Now let's move to question number 6. Okay, so this is quite good question. This looks very कि हाँ भाई कितना सारा process चल रहा है, कितनी सारी चीजें चल रही है, but it is quite easy. So name this as a variable, as I said. So this is y. Take y as e raised to x. 1 e raised to x. Okay. Then e raised to x square plus up to e raised to this. There should be this. There should be always 3 dot. When you are saying कि हाँ भाई चीजें कंटिन्यू हो रही है, तो यहाँ पे हमेशा 3 ही डॉट होनी चाहिए. ऐसा नहीं है तुम कितनी भी डॉट बना दो. Always there is 3 dots. Okay. So this is e raised to x raised to 5. So if I write it completely, so it will be e raised to x plus e raised to x square plus e raised to x cube plus e raised to x to the power 4 plus e raised to x to the power 5. Now here we have to stop. So this is our y. Now write what to do. That is to do. So what we have to do, we have to differentiate this with respect to x. That means we have to find our dy by dx. This we have to find. Okay. Now as you can see, कि हमें exponential of, we know the differentiation of exponential function, right? We know the differentiation of, we can easily differentiate this function separately. But now we have to find the differentiation of this function as a summation. Okay. So use your algebra. We know that we have an algebra. We have also did in, I have told this in my introduction video. If you are new, no problem. I will write here. So what is the algebra? That if you have two functions, say f and g. Now, if you have to differentiate f of x plus g of x with respect to x, that means if I denote the differentiation by dash, then its differentiation is given by differentiation of f of x plus differentiation of g of x. Like differentiate sum of the differentiation of both the function. Okay, so now here, so our dy by dx will become d by dx of e raised to x plus d by dx of e raised to x square plus d by dx of e raised to x cube plus d by dx of e raised to x to the power 4 plus d by dx of x to the power 5. Now differentiate it. We know that the differentiation of exponential is nothing but exponential. Now here, as you can see, this is composition of function. So what its differentiation? Its differentiation is differentiate the outer function, write the argument as it is, then differentiate the argument function, that is d by dx of x square. Then this is e raised to x cube. Differentiate the argument function, that is x cube, plus I am writing so on. No need to write so on, but yeah, I don't want to write this part also, but I know you can do it now. So this is e raised to x to the power 5 d by dx of x to the power 5. I will write the final answer here. So your dy by dx, it will become e raised to x plus e raised to x square into 2x plus e raised to x cube into 3x square. What I am using? Just differentiation of x raised to n. That is nothing but n times of x to the power n minus 1. So this is 4 times of x cube plus e raised to x to the power 5 5 times of x to the power 4. So this is your final answer, your dy by dx. That's all what we have to find. Okay, so now this question is done. Now let's move to the question, next question, that is last question of this video. Okay, so this is root of e to the power root of x, wherever x is greater than 0. ये थोड़ा सा दिख रहा है कि यार मतलब थोड़ा सा भयंकर सा फंक्शन है. कुछ नहीं, स्टार्ट योर गेम. y लो लो इसे, y ले लो इसे. So this is y of y equals to root of e raised to root x. Okay, we are like given that our x is greater than 0, so this whole thing is properly defined. Now what we have to do, we have to find our dy by dx. That's what we have to find. Okay, now let's move. So as you can see, देखो लगाओ अपना फंडा. क्या ये मेरे को कोई स्टैंडर्ड जैसा दिख रहा है? नहीं. क्या ये मेरे को क्यूबी रूल में दिख रहा है? नहीं. एक्सआर क्वोशिएंट रूल में दिख रहा है? नहीं. तो अब तो क्या बचा? कंपोजिशन ऑफ फंक्शन. और हाँ, मेरे को ये कंपोजिशन ऑफ फंक्शन में दिख रहा है. सो नाउ व्हाट our dy by dx, this will be differentiate the outer function. So we know that our outer function is root of some inside. So what we do, differentiate the outer function, keep the argument as it is. We know that root x, or we say x raised to n, its derivative is given by n times of x raised to n minus 1. So this is, say, f of, like, argument is our, name it as f of x. So I will write it as so this will be 1 upon 2 times of, because if I used to say, because root x, its derivative is given by 1 upon 2 root x. So this will be 1 upon 2 times of root of, write the argument as it is. Here our argument is not x. Here the argument is x, but here our argument is e raised to root x. So this is, now differentiate the argument, that is d by dx of e raised to root x. If I write the reason, if you are quite confused, so I am writing the reason, that is the differentiation of root of f of x by chain rule. You can easily find that it is given by 1 by 2 times of root of f of x, then d by dx of your argument, that is f of x. Okay, so I have just used this. Now let's move to ahead. That is, this is 2 times of root of e to the power root x. Now differentiate it. Now here also your argument is root x, not x. So we know that it's exponential differentiation of e raised to x is e raised to x. So this will be e raised to, with this with the argument as it is. Then differentiate your argument, that is d by dx of root x. Now this will be 1 upon 2 times of root of e raised to root x, e raised to root x, d by dx of, sorry, I have to write the d by dx here. Okay, so we know that d by dx of root x is nothing but 1 upon 2 root x. So just write it in simplified form. So what you get, your dy by dx is, if you want to like write it in simplified form, so this will be root of e raised to, because this and this will cancel out, so this is root of e raised to root x divided by 4 root x. This is your simplified dy by dx. Okay, so done. सारे क्वेश्चंस हो गए, 6, 4, 5, 6, 7. Okay, that's all for today's video. Now I think you guys are keep practicing each and every questions of your book, because you should, because NCERT बुक में वैसे ही बहुत सारे क्वेश्चन होते हैं. आप लोग अगर इसकी भी प्रैक्टिस कर लोगे ना, ये भी बहुत इनफ हो जाता है. Okay, so that's all. Now let's move to, in next video we will complete this exercise, your exercise 5.4. Or till then, goodbye. Please keep practicing, keep doing questions, please do these questions once by yourself. And let's meet in the next video. Goodbye. Please like, share, and subscribe my videos. Thank you.